Hello and welcome. Today our group gonna present the Apache Jena tutorials. Hopefully after watching these tutorials you guys can master the basic of Jena, the way they structure the database, the syntax to write it in Eclipse, Java, some use cases, and also a little comparison between Jena and other SQL. Alright, let's get started. Here is the address of the website of Jena, jena.apache.org. It is free and open source. Also, this letter J, as Dr. Wei has mentioned, is for Java. It is written in Java and for use in Java. So, we're going to use Eclipse to write some piece of Java code that can manage and use Jena database. Alright, first off, let's make it quick and simple. The installation, it is running Java, so you need to install Java Jdk. But make sure you got the 1.8, JDK 1.8, because as I tried on Java 14 and Java 15, the newest ones, it doesn't work. So make sure you have Java Jdk 1.8 installed. Eclipse, the newest one, as new as possible. And it's the final thing is the users library. You're gonna create a users library, download the library from the website, and then import it into Eclipse, and it's ready to use. Right. Let me show you how it works. All right. In here, I have an Eclipse download page for Eclipse IDE for Java developers. Just download the right version for your OS. Next, you need to also download the Java JDK. Make sure the version is 8. And click on download the right version for your OS. And then go to the Apache Jena website. Click on download. And you need to download the library so we can use it later in Java in Eclipse. So you can download this one. Alright, minimize that. Eclipse is ready. Let's open it up. Okay. The first thing you need to do is create a user library in Eclipse. So go to Preference, Java, Build Path, User Library. And go ahead and create a new library. Give it a name, Jena, L-I-B. Click OK. And then you're going to add external jar. This is a downloaded file from the Apache Jena website. You extract that, go to the extracted folder, library, lib, and then select everything. Open. Everything now is in the Jena library. Just apply and close. Now, go to New, Create Java Project. Give it a name, Jena. Make sure you select Java 8 and then finish. There, in the source, right click new class. Create a new class for package. Give it a name or leave it as default. That's okay. For the class name, just say start. And click public static void main. Or you gonna need to create manually. No, I'm lazy. Just click on that and finish. There. Let's create everything for you. Now, one more thing you need to do. Right click on a project, build path, add libraries. Select user library, next, and then choose the library you just created. Finish. Alright, now both Java library and Jena library is in your project. You are ready to go. Let's play with Jena Apache for a while with some simple code. Alright, let's create a string, call it URI, Uniform Resource Identifier. It is like an address where you place a specific data. Let's call it HTTP ABC data and the name of the first element. Let's call it animal1 semicolon. Okay. Now we also need to create an empty model. So just say model m equals model factory dot create default model, and then semicolon. Okay. If you hit enter, they just automatically import the needed library for you. This model is an error. Okay, that's because we didn't import the model. So just move the mouse to the model and then click import. Done. Okay, so in previous version of Apache Jena, they use different name for library, hp.com something. It's complicated, and who wants to remember that, right? So just whenever you see an error because of forgot import something, just move your mouse there and look at the suggestion, look for the import. Done, right? Okay. Each element in the data is called resource. So let's name the first resource and add some property to it. So I'm going to have the first resource as animal1 equals. You add that to your model. Create resource semicolon. Okay, one more error. Just about the import stuff. Okay, make sure you choose the Jena.rdf.model. That's the right thing. Okay. All right. So that data is just a name in Java, so you can call it just a variable name. Now give it a name, give it some content. So animal one dot add property dot add property there, and give it a type vcard. See, when you hit enter, it just automatically add the library vcard, vocabulary vcard to it. and the name for that animal 1 is elephant, semicolon. Alright, so first data already in. Let's see what does it mean. Let's kind of debug it. So you're gonna write that model m dot write, and you're gonna write it in system dot out, and then semicolon. Okay. Oh, one more thing. You're gonna create this animal 1 with the URI address of this one. So let's call it URI. You're gonna create that resource with this URI. So put that in the parentheses. Alright, save it. Run. Now, right here, it gives you an XML script, which is so complicated. So let's make it written in turtle mode. Save. Let's run it again. Right, a little simple. You got an URL for your data, and in that you got a vcard type, and the data is elephant. Okay, so we already complete the installation. It seems smoothly, and since it's based on Java, we are still a little familiar with the code and how we write things up. That's cool. All right, more on syntax. Okay, when you declare a resource and add a property to it, you don't need 2 statements. You just need 1, right? Because this part is actually right here. So you just bring this up to here, and that should be it. All right, let's try a new resource. Animal number 2, m dot create resource, and you're gonna need an identifier for that. So create a URI number 2 that is the same, but just change animal 1 to animal 2, semicolon. Create resource in URI2 with URI2 dot add property. Property. So add property, this one, vcard .fn, and the name of that is lion. All right, let's run to see if the data goes right. It does, right? Okay. Now, for sure, we don't want to see things like this when we need to see the database. We need to see the data, the list of animals, right? Okay. In Jena, they have a method can list all the data name with type. That is res iterator, resource iterator. Let's call it I, and that is for model M. List subject with property, and the only argument you need for this method is property. So enter, and then the property we just declared for all our data is vcard.fn. Right? Semicolon. Alright, error right here. Import issue. Okay, import Jena.rdf sounds right. So import that in. We are good to go. Next. So we're gonna list them one by one, use a while loop, and the condition is I has next. If I has next, then we're gonna print that, print which, print that resource. And then they need the property. Oh, fat finger. Property get string or two. If we have two string, yes, we have two string. Okay, two string. There. All right, let's try if that works. Oh, okay. So next resource get property. So that's a string. This look like array, right? But it's data. That data. Data. Okay. So instead of two string, we're gonna use get string. So it's gonna give us just the name. Let's see. There. So they just list out everything in the data. The thing we need, everything that I have to share with you about Jena, how to install it, how to use the syntax in the basic level, in the introduction level. And that is made possible by these two reference in the Jena Apache.org tutorial, and also the Java doc. Right here, and the Java doc, it has all the method explained and the usage and what argument you need, so you can refer to this document for those type of question. And for this one, here's how an RDF represents in Jena. So when we write a code like in the when we create a model, resource, animal, add property, here's the graph of that. So right here is the URI, right here it's a type, and in here you got the name of the data. You can also add another type of data within one URI. And here's the syntax for that. For any more advanced question, you can refer to Apache Jena. And really want to be an expert, read all of these things. I think that will help you to be an expert. All right, now Trang will share with you some types of use cases.
So as you already know, some basic information from the presentation, I'm going to introduce you with the Jena Apache use case and industrial adoption. First, we know Jena Apache can store a graph, and what is graph and why it's so important in many ways in our life, in our application. Graph, as we know in algorithm, is not only about what we're gonna do with the vertices and edge. It's about we're gonna store a set of triple. What is triple is going to be a subject, predicate, and object. And based on what we store in graph, we can apply it to analytics like social networks or recommendation engine like Google. And we also use in knowledge graph like what happens between people, places, and events, and customer database or product catalogs. The happening between people, places, event we can use in national security, like detect what is terrorism. And in this specific use case, we're going to talk about, we're going to build a search engine based on semantic search base, and we're going to use Apache Jena. So what is semantic? That's basic information about what the meaning of language or logic. If we tie a sentence like apple is red to a computer, the computer understand the apple is red. Like they're gonna send apple in object, and then red is color. No, the computer only understand is only work with the binary 0 and 1. So how to train the computer understand the semantic or the meaning of the sentence is about that. Is about we're gonna talk about semantic analysis. The semantic analysis, we're gonna help the computer understand include the structures, occurrences, and the idea of what we write for the computer. And one of the example of semantic search is in Google. Like if we type Usain Bolt in the Google search, so how many people in the world have the same name? Maybe 1,000 or 1,000,000. So how can the Google know that's the athlete, and they're gonna pop up the information for us? It's because Google know right now the most famous people have that name. It's gonna be an athlete, so that's why it gives us like the information of the athlete. It's different with the keyword search base. Like when we type a keyword, the search engine gonna search for what is the most occurrence of that keywords in the result, and then send back to us. So Google, they use very large amount and very open information for search, but in our case, go back to our case, we're gonna limit it in inside a domain of ontology for the search engine. And so back to some just for review. So what is the domain? What is ontology? So domain it can be anything in our life, like a college, a sport, or a subject, or a famous location, a tourist spots, and so on. And ontology is gonna working on that domain is gonna build some concept or definition or descriptions, properties, and relations. To build an ontology is just basically in OOP, it's just like we build a class. First, we need to know what is the domain of that ontology. And then we're going to list all the concepts and all the relations. that's related to that domain, and then we can use a tool named Prodigy that create a file with extension OWL. And then when create a file, we just consider the ontology for some domain. It's just like a class, a huge class with many subclasses. In the class also have some property in instance or data type or behavior and so on. And this is how ontology look like. For example, the ontology we are having right now is include some subclasses like faculty, research, and some property of it, and so on. So we already know about ontology. It builds some structure that includes some information, property, and relation. But we also need to collect all the data from different sources, like PDF or HTML. How can we store that data and have the search engine query that data for us? So the data going to store in the RDF. As you already know, RDF is going to store triple in a triple form, subject, predicate, and object. And we can view the RDF in XML file, right here. So in summary, we can build a search engine that search based on semantic. And then we can pick a domain. For example, in this case, we pick computer science is our domain, and we're going to build the search engine for people, like a user can go to that and search for a faculty CV from some design university, and then what the faculty's research area, and then based on that query. And so what is the step of doing all the building search engine with the explanation? So it's going to go through several steps. First, we're going to crawl the document like doc, PDF, XML, HTML, and so on from various university, and then we classify faculty profiles. Then we're going to convert the unstructured text to an RDF form. So first we collect the information and then we convert it to RDF, and then we're going to build the ontology for computer science domain. So we already have ontology, we already have RDF. We're going to save those data in Apache Jena. So this is where the Apache Jena is going to use to store the whole information we already built. And then we're going to use the SparkQL query language on data to get the information for query. This is the real-time semantic search engine architecture. So as you can see, this have a different layer between web, core, service. This is ontology, and this is the Jena Apache.
Hello everyone, my name is Aparajita, and today I'll be talking about Apache Jena and its comparisons with other, its limitations and comparisons with other SQLs and no SQLs. So I'll just share my screen and start with it. So I'm going to be talking about the limitations and comparisons of Jena Apache. First, we're going to talk about TDB2. Apache Jena uses TDB2 for RDF storage and query. And before it used TDB, it used to earlier use TDB1. TDB1 and TDB2 are not compatible. They do not go well with each other. In TDB2, there are no limitations on size for transaction. There's also better control with transactions as it solves the backlog problems, and there is no delay in updates. The name for base package of TDB2 is org.apache.jena.tdb2. Over time, when updates occur, DDB2 databases continue to grow. They can be compacted by using database mgr.compact dataset um, as data graph. This following command, as you can see on the screen. And then TDB2 databases can be backed up by using this command. Now we're going to compare Apache Jena, which uses TDB, versus MongoDB. Uh, Apache Jena it uses RDF store as its primary database model, and whereas MongoDB, its primary database model is document store. Apache Jena does not have a secondary database model. MongoDB uses a search engine as its secondary database model. Apache Jena has an overall rank of 102, and MongoDB has an overall rank of number 5, which shows that MongoDB is better compared to Apache Jena. The developer is Apache Software Foundation for Apache Jena, and the developer for MongoDB is MongoDB Inc. Both Apache Jena and MongoDB are open sources. The implementation language of Apache Jena is Java, whereas the implementation language for MongoDB is C++. Apache Jena has a data scheme. MongoDB is schema-free. Apache Jena has no SQL, and MongoDB has read-only SQL queries. Next, I'm going to compare Apache Jena versus Oracle NoSQL. Apache Jena, as talked earlier, uses RDF store as its primary database model, whereas Oracle NoSQL uses key value store as its primary database model. Apache Jena does not have a secondary database model, whereas Oracle uses relational DBMS as a secondary database model. The developer of Apache Jena is Apache Software Foundation, and the developer of Oracle NoSQL is Oracle. Apache Jena has a rank of 102, and Oracle NoSQL has a rank of 82, which shows Oracle is still better than Apache. They both are open sources. The implementation language of both Apache Jena and Oracle NoSQL is Java. Apache Jena has a data scheme, and Oracle NoSQL has an optional data scheme. Apache Jena has NoSQL, whereas Oracle NoSQL has a SQL like DML, DDL. Next, I'm going to compare Apache Jena with Virtuoso. Apache Jena has primary database model is RDF store, and Virtuoso uses multiple primary database models like RDF store, Graph DBMS, search engine, native XML DBMS, relational DBMS. Apache Jena's rank, it has overall rank of 102, and Virtuoso has an overall rank of 110, which shows that Apache Jena is better than using Virtuoso, but they all have their own ups and downs. They both are open source. The implementation language for Apache Jena is Java, whereas the implementation language for Virtuoso is C. They both have a data scheme, And Apache Jena has no SQL, whereas Virtuoso has SQL. Next, I'm going to compare Apache Jena with Microsoft SQL Server. Apache Jena has primary database model is RDF store, whereas Microsoft SQL's primary database model is relational DBMS. Apache Jena does not have a secondary database model, whereas Microsoft SQL Server uses document store and graph DBMS as a secondary database model. Apache Jena's overall rank is 102, and Microsoft SQL Server's overall rank is number 3, so it's the best so far compared to the other. The developer of Apache Jena is Apache Software Foundation, and the developer of Microsoft SQL Server is Microsoft. Apache Jena is an open source, but Microsoft SQL Server is commercial. The implementation language of Apache Jena is Java, whereas the implementation language of Microsoft SQL Server is C++. They both have data scheme. Apache Jena has no SQL, whereas Microsoft SQL Server has SQL. These were my references. Thank you.